The official version of Earth's formation, a scientific perspective. The formation of Earth, like other planets in the solar system, is part of the grand process of the universe's creation. This story begins approximately 13.8 billion years ago with the Big Bang, which marked the origin of space, time, matter, and energy. Formation of the solar system. Around 4.6 billion years ago, in one of the arms of the Milky Way galaxy, a giant cloud of gas and dust began to form our solar system. This cloud, known as the solar nebula, consisted primarily of hydrogen, helium, and heavier elements created in the cores of supernova. Under the influence of gravity, the cloud began to contract, spinning faster as it condensed. At its center, a protostar, the future sun, formed. The remaining gas and dust coalesced into a rotating disk, where the first planetesimals, the building blocks of planets, began to form. Formation of Earth took shape through collisions and the merging of planetesimals, small bodies made of rock and metal. These collisions generated immense heat, leaving the young Earth as a molten sphere. Over time, heavier elements like iron and nickel sank to the center, forming the core, while lighter materials rose to the surface, creating the mantle and crust. About 100 million years after Earth's formation, a major event occurred known as the Giant Impact Hypothesis. A Mars-sized protoplanet, referred to as Theia, is believed to have collided with Earth. The debris from this collision was ejected into space and eventually coalesced to form the Moon, cooling and atmosphere formation. In its early stages, Earth was extremely hot, with a surface covered in molten lava. As the planet cooled, a solid crust began to form. Volcanic activity and outgassing released gases, creating a primitive atmosphere composed of carbon dioxide, hydrogen, methane, and water vapor. Water likely arrived on Earth through comets and asteroids, which carried ice. Over time, this water condensed to form the first oceans. The emergence of life. Around 3.8 billion years ago, the first forms of life, simple microorganisms, appeared in Earth's oceans. This process, known as abiogenesis, remains a subject of scientific investigation. Life may have originated through chemical reactions in an organic-rich environment or been brought to Earth by meteorites. Photosynthetic organisms began to release oxygen, which gradually accumulated in the atmosphere. This led to the Great Oxidation Event, around 2.5 billion years ago, altering the atmospheric composition and enabling the evolution of more complex life forms. Modern Earth. Over billions of years, Earth has undergone continuous changes due to plate tectonics, volcanic activity, and meteorite impacts. Continents formed and drifted apart, climates shifted, and life evolved, becoming increasingly complex. Today, Earth is a unique planet with a biosphere that supports billions of life forms. Its history is a testament to the powerful processes at work in the universe and the delicate balance required for life to exist.